So for today's problem, we'll be trying to find sine squared plus cosine x plus 1 equals 0. So we're going to be finding what x is. So the first thing we would have to do is to make sure we have like terms. So if we remember back to our helpful hexagon, there's an identity that's focused on dealing with squares, in which that would be the Pythagorean identity. So this one for sine squared is what we're going to be getting rid of. So let me pull it up. In a helpful hexagon, we know that cosine squared plus sine squared equals 1. So cosine squared plus sine squared equals 1. So if we quickly write that off in the side in pencil, squared plus cosine equals 1. We can use the not order of operations. We can just separate this to get sine squared alone, in which sine squared x is equal to 1 minus cosine squared x. And that's what we can plug in to here to make sure all the terms are like. So we rewrite that as 1 minus cosine squared. And then we rewrite this part again, so cosine x plus 1 equals 0. And then for this part, we just merge them together, so we rewrite it as negative cosine squared x plus cosine x plus 2 equals 0. And then for us on the next step, we would have to break this up into two parts in which we would factor it. So if we factor this whole thing, it would lead to negative cosine x plus 2 with cosine x plus 1, and then equals 0. Now we would solve it separately, so if we go here, this one will be negative cosine x plus 2 equals 0. X equals negative 2. You know this one would not have a solution since this wouldn't exist. So this one would not work. Now if we go back over here, we find that cosine x plus 1 equals 0. If we rewrite that as cosine x equals negative 1, we know from our unit circle that this would only be right in the unit circle if it would be this one right here, in which it would be negative 1, 0. So meaning that the answer for x is equal to pi. And then that's the answer.